For today's lesson, we are going to talk about the law of cosines and the law of sines and triangle area. Particularly, we've been talking about triangles and solving triangles when we're working with a right triangle. But what if you don't have a right triangle? What if you have some other type of triangle and you don't know what the angle measures are, or you know for certain that there are no angle measures that measure 90 degrees? How do you solve one of those triangles? So this is where law of cosines and law of sines will come in. So just as a reminder, solving a triangle means you're finding the measures of all the missing sides and all the missing angles. So we know that for right triangles, we can use SOHCAHTOA, but we need new rules in order to solve oblique triangles. Now, why doesn't SOHCAHTOA work? Well, because it relies on having a hypotenuse. The hypotenuse has to be across from a right angle, and in anything that's not a right triangle, this won't work. So, an oblique triangle, which is a triangle that does not have a right angle, we will have law of cosines and law of sines, but before we get into those formulas, we need to understand what we consider standard notation. So, here's a triangle. Now you'll notice that the angle measures are labeled capital A, capital B, and capital C. So each angle or each vertex is named with a capital letter. Now, the sides, you'll notice, are all lowercase letters, but it's not random how the sides are labeled. The side that's opposite each vertex is denoted with the same letter. So across from angle A, you see side A. Across from angle B, you see side B. And across from angle C, you see side C. So the side opposite each vertex is denoted by the same letter, but using a lowercase. Now, in order to solve an oblique triangle, you need the measure of at least one side and any two other parts. So it could be one side and two angles. It could be one side and then an angle and a side. So as long as you have one side and you have two other parts, you'll be able to solve the triangle either with law of cosines or law of sines. We're going to start with law of cosines. Now for law of cosines, you are going to use this formula if you are given all three sides, or if you're given two sides and an included angle, so side, angle, side. Now, you'll notice that I've only filled this in at the top part of the box. The reason is because there are two other versions of it, but it's really the same formula. So a squared is equal to b squared plus c squared minus 2bc cosine of a. Now, the other two forms are really just the same, but it really depends on how you've labeled your triangle or how the triangle is already labeled for you. You can always feel free to relabel the triangle so you only have to know that first formula, or you can feel free to use any of the other two forms. So b squared equals a squared plus c squared minus 2ac cosine of b. And then c squared equals a squared plus b squared minus 2ab cosine of c. Now the alternate form is similar to what we had earlier where we have different forms of this, but this is just written in a way where you have cosine of a by itself, and that way it makes it a little bit easier if, say, you have all three sides and you want to know what the angle measure is. This way it's already been moved over to one side for you. So really take that first, a squared equals b squared plus c squared minus 2bc cosine of a. If you take that and you want to get cosine of a by itself, so in this case we would add 2bc cosine of a to the other side, subtract the a squared over to the right, and then divide by 2bc, and that would give us cosine of a. And that's exactly how we get this alternate form. But just know that this is really the same as that very first formula you have written there. It's just that it makes it a little bit easier to find the angle measure. Okay, let's go ahead and use this formula. So example 1, we have a triangle that's labeled here for us, and you're asked to solve for side C. Now you have side A, that's 16, across from angle A, and side B across from angle B, that's 10. So we have side A, side B, and we have angle C. So if we use that third form of the law of cosines, that will help us solve for C. So C squared equals A squared plus B squared minus 2AB cosine of C. Plug in everything we know. So we have 16 squared plus 10 squared minus 2 times 16 times 10 times cosine of 110. Now here you can put the entire thing into the calculator. Just be aware that you want to make sure that you're not doing just 16 squared plus 10 squared minus 2 times 16 times 10, hitting enter, and then multiplying by cosine of 110. The rules of PEMDAS still apply here, so you want to do the multiplication first before you add or subtract. So if you do the entire thing into the calculator, your calculator will follow rules of PEMDAS. So we get C squared is about 465, but we need to find what C is, so take the square root of both sides, and we get C is about 21.6. Let's do another example. This time we're going to solve for an angle measure. Okay, so the way that this triangle is labeled, we know that across from angle A is side A, that's 20. Across from angle B is side B, that's 15. And across from angle C is side C, that's 8.3. Now, since we're trying to solve for angle B, I'm going to use the alternate form, where we move cosine of B over to the other side. So we have cosine B is equal to A squared plus C squared minus B squared all over 2AC. And now it's just a matter of plugging everything in. Now again, if you put this into the calculator, if you want to put that entire right-hand side into the calculator, just be sure that you put the 2 times 20 times 8.3 all in parentheses, so your calculator knows that the entire thing is in the denominator. Otherwise, you can do what I'm going to do here, which is I'm just going to find the numerator and then find the denominator and write it as a fraction for now. Now, if I'm trying to solve for angle B, now we are trying to get an angle measure in degrees, we are going to take the inverse function, so inverse cosine, of both sides. So taking the inverse cosine of this side leaves us with just B by itself, and then plugging that into the calculator on the right, we get that B is about 42.7 degrees. So that's using law of cosines to help us solve a triangle. Now we're going to use law of sines when you either have two angles and a non-included side, or two sides and a non-included angle. For two sides and a non-included angle, please do always write it as side-to-side angle. If you're going to abbreviate it, please never abbreviate it as angle side-side. So here's law of sines. A over sine of A is equal to B over sine of B, which is equal to C over sine of C. Now, you're not always going to use, in fact, you're never going to use all three of those ratios at once. At any given time, you'll just use a combination of two of those ratios, and you'll solve by cross-multiplying. Now, the way that it's written here, it just means that you can use A over sine of A equals B over sine of B, or you could use B over sine of B equals C over sine of C, or you can use A over sine of A is equal to C over sine of C. It really depends on what information you already have and what you're trying to solve for. So let's take a look at example 3. Solve for A in the triangle below. So for what we have here, we have angle B, we have angle C, and we have side B. Now we also can figure out that third angle here. That's just subtracting from 180 using the triangle sum theorem, and we get 129 degrees. So for us to solve for A now, we can simply use, well, we have A, we're trying to solve for side A, we have angle A, we have side B, and we have angle B. So we can use A over sine of A equals B over sine of B and plug in what we know. So now we have a over sine of 129 equals 210 over sine of 20. And we'll cross multiply and we get a times sine of 20 equals 210 times sine of 129. And we'll divide both sides by sine of 20 to get a by itself. Putting that whole thing into the calculator, we end up with a equaling about 477.2. Okay, now we have some area formulas that we're going to go over. And these area formulas, now you know how to find the area of a triangle, probably you know the 1/2 base times height. Now you're not always going to have the height given to you, and it might be actually more difficult to find the height than to just use one of these other formulas. Now this first formula that we're going to talk about is derived from the law of sines. So say you have sides A and B, and they are adjacent to angle C, so they form angle C. Then the area is simply equal to 1/2 times A times B times sine of C. So for any triangle, if you have two sides and the angle in between, you can easily find the area. There's no need to try to find the height of the triangle. Now similarly, similar to the law of sines, where you have different versions of this depending on which pieces of information you have or how you've labeled your triangle, these two are really just the same formula as well. The area is equal to 1/2 BC sine of A, and the area is equal to 1/2 AC sine of B. Now let's see this being used in an example. So here we have a triangle, and we don't have it labeled. So we can go ahead and label it ourselves however we'd like. So I'm going to label this angle here A, and this angle here B, and this angle here C. Now the way that we've labeled angles A, B, and C doesn't matter, but the way that we label the sides has to correspond with the way we've labeled the angles. So across from angle A, that's 13, so that's lowercase a, and across from angle B is lowercase b, so that's 8. Okay, so now we're trying to find the area. We have side A, we have side B, and we have angle C, so we can go ahead and use the area is equal to 1/2 AB sine of C, and plug in what we know. So 1/2 times 13 times 8 times sine of 130. And this comes out to be about 39.8 square centimeters. So notice how in this problem, even though you didn't have the height, and you actually didn't have the base either, well, depends on which one you want to make the base, we don't actually need to go about solving for those in order to find the area of the triangle with this new area formula. Now there's one other formula to finding area of a triangle, and it's called Heron's formula. So this area formula is used when you are given 3 sides of a triangle. So here it is. Area is equal to the square root of S times S minus A times S minus B times S minus C. Now what is S? S is equal to, well, you take the sum of all 3 sides, A, B, and C, and divide it by 2, and that gives you S. So anytime you use this formula, you have 3 sides of a triangle. You need to first find S. Once you find S, then you can plug into the formula with all your values of A, B, and C, and the value of S that you just found. Let's look at an example together. Find the area of a triangle with side lengths 7, 9, and 12. So let's start by finding the value of S. So that's 1/2 times A plus B plus C. That would be 7 plus 9 plus 12. That's equal to 28, and divide that by 2, we get 14. Now we can find the area. The area is the square root of 14 times 14 minus 7 times 14 minus 9 times 14 minus 12. And simplify that, so we have 14 times 7 times 5 times 2. That comes out to be 980. Take the square root of that, and that gives us that the area is about 31.3 square units.